So now we are going to see what is mixing spurs. So in the electrode and receiver, we have assumed ideal RF and IF mixers. So ideal mixers means they will not have any loss and they will just produce sum and difference component. It is not mathematically always that they will produce sum and difference component alone, but they might produce other frequency components also. So in practice, the mixers will deviate from analog multipliers, introducing undesirable effects in the received path. See what block diagrams we are seeing is if everything is perfect and working fine, but in practice nothing is perfect, right? So these mixers are not ideal. So when they should produce sum and difference components, sometimes they produce other signals also. You can an example you see if you multiply an RF input by a square wave LO, even if the LO is applied to the mixer as a sinusoid. Mostly local oscillators we are going to use sinusoidal waveform only. In case if I'm going to use a square wave type local oscillator and I'm going to multiply that with my signal, then what will happen? So this internal sinusoid or square wave conversion is inevitable in the mixer design. So mixers are oscillators. So just a function generators. In function generators, you have several options like sine wave, square wave, triangular wave, right? So naturally, when with sine wave, if I'm not able to achieve something, if I change the oscillator type, if I'm going to get it by square wave, I can very well go for it. Okay. An example is considered. That I'm going to multiply a signal with the square wave. Okay, so we must therefore view multiplication of input by all the harmonics of LO. You know that square wave is a periodic signal, and all periodic signals will have Fourier series. So when I'm going to multiply the input by uh, RF input by a square wave, I can replace a square wave by a Fourier series expression. So Fourier series will have its fundamental frequency and all the harmonics. So I can say the first RF mixer will produce the frequencies. See this one, omega in plus or minus m into omega LO1 as per the Fourier series. And this is going to go as input to the IF mixer. It is going to produce its own Fourier series terms, omega in plus or this frequency as it is, plus or minus n times omega LO2, where m and n are integers. So ideally m will be 0 and n will be 0. So in that case, omega in will definitely, ideally, sorry, m will be 1 and n will be 1. So when m is equal to 1, first IF1 will get. When n is equal to 1, you get the second IF1. And all these pluses will be minus. Plus will be filtered by your low pass filter, right? So ideally, m and n value should be 1. But practically, m and n value will be 1. It will also be 2, 3. It depends on your signal. For desired signal, see here, m value equal to 1 and n value equal to 1. If you put m is equal to 1, n is equal to 1, and if you ignore all the plus sign, you get omega in minus omega LO1 minus omega LO2. Omega in minus omega LO1 is your first IF. And this signal minus omega LO2 is going to be your second IF. So if you have an interferer omega INT, it is converted to the same IF, it corrupts the signal. That's what we said in band interferer. Assume there is a frequency omega INT, and it is also having this form omega in plus or minus m omega LO1 plus or minus n omega LO2 is equal to the desired signal. If this happens, then this will going to corrupt your signal. This such interferer is called as mixing spur. Spur is an interferer which is going to cause from the harmonics of your LO. Remember, it is going to be harmonics of your LO. Image is going to be a separate signal which is away from your signal. But spur is going to be caused because of the oscillators what you use inside the block diagram. It is not an externally caused phenomenon. It is caused internally because of the oscillators. When this condition is satisfied, your interferer and signal will be at the same frequency. Your signal will be completely corrupted. So this mixing spur means because of the non-linearity of my mixer, and I can represent the mixer, I can represent the LO as an infinite Fourier series. It will have all harmonics of LO1 and LO2. One such frequency omega INT, which is going to match with your input signal, is going to be called as mixing spur. The image also you can reject them because it is going to occur at a frequency far away from your actual thing. But this is going to be occurring exactly at your message frequency itself. So this is very, very difficult to remove or control.